Bystronic is a leading global supplier of system solutions for the sheet metal industry. We provide laser cutting systems, bending systems, automation, software solutions, and comprehensive services. Sorry, I need a sip. Ah.
He's good, no?
Mommy.
Let's say he has a confident voice, yes.
Shall we? Client happy?
Client happy, but please get to the end of the line this time and add a little verve.
The verve is there. You may not be able to hear it right now, but you will in post-production.
In post, we are in...
We offer worldwide presence and competence. We speak your language and understand your needs. We are here for you. Sorry, we are here for you. I mean, I hear the words, but I'm not getting anything from them, you know?
Could you please just say the lines?
May I?
Please.
It means that we offer much more than just a machine. We support our customers with flexible financing models, training, maintenance, a long-term spare parts service, phone hotlines and online support. And we also operate local sales and support offices in many, many countries.
Yes. Now you see, now it's coming alive. We should be saying this. It is more text, though, so we will have to renegotiate with my agent.
Can't you just record it and we'll look at it later?
Well, I'd love to, but my agent would kill me.
If only. Fine then, continue with the script.
Right you are. Where were we?
At customer service and post-sales services, would you believe?
Rolling.
We don't simply develop machines that cut or bend sheet metal. No, our customers need flexible systems for ever-changing order positions and batch sizes. Automation to achieve top productivity with integrated systems and the right software that cross-links everything. Bystronic stands for Swiss quality. Sorry.
Really?
Swiss quality, I mean, it's a bit of a cliche, isn't it? And actually, while we're at it, your slogan, best choice, kind of sounds like we've just won the buzzword bingo.
Guys, if you want to sort this out, I'm just going to pop out for a smoke.
Let me explain. First of all, Swiss quality. Do you know the Bystar fibre? The Bytrans Cross or Bysoft? Have you ever seen them laser cutting and bending those sheets? It's like butter. Once you've seen it, you can't help but be excited. The beauty of a laser cut. The precision of a bent metal sheet, from very small to very large, but all with the precision of Swiss clockwork, perfectly formed and expertly fitted. Now, best choice. When you say yes to a partner, be it in business or private life, you make a commitment to the future. Bless you, Katie. Now, you're still young, but one day, you're going to want someone for the long run. Someone who shares your vision for the future. You see, at Bystronic, we think about tomorrow's sheet metal processing. We have some footage of that, right? In what we call the Smart Factory, variable orders will be produced automatically on flexible systems. A clear vision and state-of-the-art technology means cost and process optimization, which in turn means higher earnings. And who's behind this success? The employees of Bystronic worldwide. Now, you'll say that's just another cliche, but nobody else sets new standards like they do, with their enthusiasm, their ideas, and their know-how. Actually, I stand corrected, because our success is also due to our clients. It's their feedback that we use to develop new technologies. And until they are perfectly functioning, we will not launch them. And none of our employees will settle for less. Not in Asia, not in America, not in Europe, not in Switzerland, nowhere. And that's what we mean by best choice. I'm sorry, I think I interrupted you.
Did you record this?
Sorry, did he say something? I couldn't hear a word.
He says we're done.
Really? That looked like more words to me.
No, really, we're done. But you can stay here till 5 because it's in your contract.
Well, no, I'm more than happy to do another version. We'll just reach my agent later on. That's no problem. Gentlemen? Hello?
Dear ladies and gentlemen, welcome to the first Digital Technology Days of 2021. My name is Sebastian and I am happy to host this event today with my colleague Sarah.
Thanks, Sebastian, and also warm welcome from my side. I'm so excited to show you guys our newest products in the field of cutting, bending, and automation. So be prepared for interesting topics, innovative machines, and new features.
But before we start with those great topics, let us introduce you our experts for today, Carsten and Benedict. How are you?
Welcome, also from our side. My name is Carsten. I'm the product manager for vending. I'm happy to have all of you here. This is an event which was dedicated for Scandinavia, for Russia, for UK, and now we have nearly half of the world looking and watching us. So, good morning Denmark, good morning Sweden, good morning Norway, Huva Hyamenta Suomi, Dobry Utro, Russia, Björna Vista, or Björna Diaz, and Dien Dobre. Welcome again, everybody, for our event today. I hope it will be interesting for everybody. Before we go straight into our event, I would like to highlight one point. That's our landing page. So if you see a topic like our brand new 15 kilowatt B-Star fiber laser, or our Expert Pro, or our tool changer, or the mobile bending automation and the automation. If you see something and you want to see something more in detail, just book your individual demo with us. You can do this over our planner. We have an online planning tool, and you will find this in the chat, in the YouTube chat. So you can go straight into this and schedule your individual demonstration for your parts. So with this, I hand over to Benedict.
Yeah, also welcome from my side, ladies and gentlemen. My name is Benedict Kreisel. I'm the product manager for Bending Automation. And thanks that you are part today of our Digital Technology Day. And you are really part of our Digital Technology Day because we want to do it today a little bit interactive with you. We want to have your opinion, we want to have your questions, and we want to have your several ideas to several topics. And for this reason, we want to invite you to join us on slido.com with the code 4858. And you also have the possibility with your smartphone to scan now this data matrix code, and then you can join us in an interactive way today in these few hours of our Digital Technology Day. And also into Slido integrated is also the chat function. So you can ask us questions, we will answer your questions so that it's interactive and you have the biggest benefit out of it. So as I said, join slido.com, enter 4858 or join with the data matrix code. To have the possibility to start, if it also works on your side, we want to start with the first question to you. So our first question is, which country do you come from? This is just a test question, and please feel free to enter where you are from. So we see from Romania, Swiss, Belgium, UK, Swiss. So many people joined here all around the world, as Carsten mentioned, and it's great to see that you have joined Bystronic today for this Digital Technology Day. So we can see already 25 answers. Many of you have joined in, that's great to see, and we will follow with this also afterwards, as I said, with questions and also with an interactive way of this Digital Technology Day. So, at this point, enough from our side here, and we give back to our colleagues downstairs, and we will start with our first demonstration. So have fun.
Thanks to Carsten and Benedict. So let's start very fast. Let's start with 15 kilowatt.
As you already can see behind us, our newest member in our demo center, the new Bystar Fiber 15 kilowatt. But before we see those great machines in action, let's hand over to our software expert, Benjamin, who told us great stuff about our software Bysoft 7.
Hello, my name is Benjamin and I'm responsible for software sales in Germany. I would like to show you our Bysoft 7 software in the next few minutes. Bysoft 7 is the software to program our laser and bending machines as well as automation. Perhaps you often feel the same way. You have had a long day at work and have actually already done all of your tasks. Now you want to go home, but in the same second the phone rings and the customer wants an offer for a laser part. Or you receive an email and your customer sends you 1, 2, 3 or 100 files and wants to get a quote quickly. This is exactly where I want to start. Imagine you now receive an email like this one. Your customer sends in a request for 3 step files that you should create for him. Time is money. How do I proceed? What is the fastest way to provide your customer with an offer with laser calculation and bending calculation? Of course, I do that with Bysoft 7. In order to do that, I use the AutoPart module. With this, I have the possibility to read in various file formats, such as SolidWorks or Inventor files, or normal SAT, STP, or IGES files within a very short time. I take the 3 files that the customer send via email. In this case, these are 3 step files. I want the software to process the components quickly and create a correct laser and bending program for me within a very short time. After the import, the whole process can be started by using this button. The software recognizes the material and the thickness of the parts and unfolds it with the correct reduction values for the machines. A cutting and bending program are generated automatically. The familiar part check is of course also available in AutoPart. Bysoft 7 detects a warning for part number 3. I can now edit this part and it shows me where the warning is located on the part. Here you can see contours in the entry zone of the bottom tool. The software shows me quickly and easily where they are and highlights them with a red mark. Now I can automatically make a relief cut on the bend line and thus guarantee the quality of the part. Now I apply the appropriate cutting technology to the laser and save it. Bysoft 7 processed all parts correctly and generated a laser and bending program. Now I can switch to the Tool Setup Optimizer module to generate a bending job for my machine. To do this, I start a new job and imports the parts, including the correct debit, into the program. The Tool Setup Optimizer now supports me by bringing the bent parts into the correct order using the tools in order to minimize the setup effort on the machines. I can now see the optimal sequence for these bend parts. I can see exactly when a tool change has to take place in order to manufacture the components as quickly as possible. In addition, the machine operator receives the ideal station plan so that he always knows in which order he must install the tools on the machine. What is still missing is the part cost calculation, so that I can send the offer to my customer. I do this with our module cost calculator. With this module, I get the cost of all my operations for my components within a very short time. Bysoft calculates the material costs as well as the process costs for the components. Of course, the actual material consumption, as well as the number of pieces and the theoretically determined cutting and bending times, are also taken into account. I can now send this offer to my customer and hopefully get his order just as quickly. With Bysoft 7, it can happen that easily. This was our second part of the software presentation. Thank you very much and have a nice day.
Thanks, Benjamin. You want more information about Bysoft 7? Feel free to book a demo at any time on our landing page, right in the YouTube section on YouTube.
So, and now we're going fast and precise to our new B-Star Fiber 15 kilowatt laser cutting system with its features beam shaper, curve scan and nozzle control tool. So, Eric, it's your turn.
Good morning from my side. My name is Eric. I'm application technician here in the demo center in Gotha. And I also say a warm welcome to the world, to Northern Europe, to all over the world, to you, to our customers. And I want to show you now the big main features, the new main features of our flagship product in cutting, which is our Bystar Fiber series. In the back, we have a 3015 machine, which can handle cutting sizes from 1.5 up to 3 meter. But we are also able to build much bigger machines with a maximum size of 12 by 2.50 meters. Also, this machine is a really modular system. So you are able to handle the machine as a standalone machine and set up later on your automation, your personal set automation system to this machine, like a B-Trans Cross or a B-Trans Extended, which is our startup modular automation system for the lasers. And also you can have like storage systems attached to this machine type. So as I talked to you before, it's a 15 kilowatt laser system, so we can handle sheets up to 50 millimeters sheet thickness, which is a quite strong one. And yeah, but we can also have a different range in this machine type. We can have machines from 2 kilowatt up to, as I talked to you, 15 kilowatt. So what is also new with that machine, Sarah had told before a little bit about the key facts. We are able to set up all our Bystar machines with the beam shaper, which is a, let me say, a cleaning tool for the laser beam to make sure that we also can cut thick material in a really good quality, really good cutting quality also with higher speed than before. Then we can have the curve scan. The curve scan is a cutting gap control system, which means that we are looking in the cutting gap after the cutting sequence and check if the cutting gap is free of garbage, so we have a clean cutting gap over your whole cutting part. And the last new key feature for this machine type is the NTC or NCT nozzle centering or nozzle control tool, which means that we have a fully automated nozzle control and nozzle centering tool on this machine, so we can check the nozzle fully automated, which makes the machine a really good thing for all our automated products, but also for the standalone machine. This machine also can be attached with a nozzle changer with 64 seats for different nozzles. We can have the conveyor belt for the parts with this machine, which we recommended for machines with high laser source. So if you have like a big laser source, then we recommend to have the conveyor belt in the back. We have attached to this machine a detection eye for our fully automated cutting edge detection to make sure that your plate is every time on the perfect position to everything. And that's basically everything what we have. So now let's start to cut. As part, we have prepared a 30mm mild steel part for you to make sure that we can show you also the big parts, and this part we will use later on for something new. My colleague Carsten and Benedict will talk for this. And with this we can click on continue to start the cutting process. So now the machine will start to cut the part. Yes, we will cut the part. We have two holes in it, a big gap. We start with the big hole in it, and we will have two holes with 30 and 25mm diameter, and we will have the outside contour. You will see that we are having, or we need some time to put into the material. It takes some seconds, but then we have a good and straight cutting time, which means that we are quite good. We cut now the part. What we can say also, this machine has been set up last week. So we are in, we had finished this machine nearly at the beginning of this week. So we are brand new on Monday in our late night event we done for the German market. We have put away the foil. We uncovered that machine together with Carsten, the boss for the demo center here in Gotha, and then we cut the first parts with that machine. So you see that we have quite a clean cut. Yeah, let's look into the machine to see what is happening. And yeah, also the machine is equipped with a shuttle table for ergonomic unloading of the machine, and this shuttle table can also plates from 3x150 and 30mm. So we have a quite strong cutting table with that machine to make sure that we also can handle parts and plates like this. And the range is also, we are able to cut copper, we can cut brass, we can cut aluminium with 50mm, stainless steel with 50mm, and also we can cut mild steel as we done it now at the moment. So I think we're quite in the cutting process, or we're in the cutting process now. What the machine also do is by themselves, they make a fully automatic focus adjustment for this machine, so we are not have to change something around it. The nozzle changing tool is with a quick lock, so we are easy to change the nozzles. And now I'm shut up a little bit to let you see the cutting process will run. Okay, so part is finished. We can open the door now. Now the part is quite hot, so I just prepared me this little magnet, and then we can remove it out. First, maybe the small one. You see the cutting quality is really good, and it's hot also. And we are having the big part. It will not come out, so don't hold it so long. You see 30 millimeters cut it with the beam shaper with the machine, and with this I get back to my colleague Sarah.
So thank you, Eric, for this good news. So this 30mm part is not only there to show you how fast and efficient we can cut even in thick material on our Bystar 15 kilowatt laser cutting system. So it's also a part of Bystronic's future. And Carsten, can you tell us more about Bystronic's future?
Okay, thank you, Eric. And you have been with us at the moment when one of the parts was born for our new Bystronic 120. That's a new upcoming bending machine. This will be the start of our new flagship series as well. It's the Bystronic 120. It's a new bending machine we will launch later this year. And you have been seeing now one of the first parts. What is the highlight? No? We can cut now these parts of the machine, for example, frame parts. The frame is 30 millimeters with our own laser, very efficient. And that's what we wanted to do here now with the first parts. And the Bystronic 120 is a new product. The idea came out when we have done a workshop with customers. We do this several times per year with different groups to find out what are new products which are interesting for the market. This product or this workshop was dedicated for automation. This was mid-size automation. So we have already the mobile bending automation for the Expert 40 and Expert 80. And we have the big automation, the bending cells, and we've got from the market the feedback we need something in the middle. And in this workshop we discovered we need also a new bending machine in the middle, not just the automation in the middle. And this is this new bending machine, the Bystronic 120. 120 stands for 120 tons. It has a bending length of 2 meters, so it's a really compact machine. There will be also one available with 2.5 meters, so 2.5 meters. But the first machine will be 2 meters. With 120 tons, you are really, really flexible when it comes to thin materials anyway, but especially to thick materials as well. That's something for job shoppers where you need flexibility and have really maybe small floor space for an additional machine, and your typical parts are in this size. Then you have a really flexible horse, bending horse or working horse here. So with 120 tons, you can bend easily up to 8 millimeters over the complete bending length, but you can bend also, for example, 20 millimeters on about 1 meter. So 20 millimeters is not so bad. You find these parts typically in the agriculture industry, but also the transportation industry, everywhere there. You find this kind of parts. So the machine is really flexible, and thin material we can bend anyway. The longer bending lengths as well, 2 meters, was also a request from the automation side, because the people wanted to have some more space for station bends or station setups of the machine. So this is at the end, this was the outcome. We defined our mid-size automation, and we defined also our new mid-size press brake, and this is called Bystronic 120. You have seen the born now of one of the first parts, and yeah, this machine will be launched later on. I just want to highlight again, on our live stream, you can book now a live demonstration. For example, for the laser, you can send us the parts you want to cut, and we can do this then live with you in your individual demonstration. We have done in 2020 more than 200 web demonstrations, so worldwide, for customers worldwide, via the web. So we have all the equipment available, and we can do this for you all around the world, and 24/7 more or less. We have done something like this at the beginning of the week for Australia, for example, in an event, but we can do also your event, individual demonstration at the time you request us for. So this is available now for booking, and with this I hand over back to Benedict.
Yes, was a good hint regarding the material thickness and regarding the customer workshop. Why do we do this interactive? Because we want to have your feedback to also develop our products further for the future, and this is always very beneficial to have here your feedback. And for this reason, we want to have our second question for you, want to have an overview. If you use a laser cutting system from Bystronic, what is the material thickness you mainly cut with this system? So please feel free to join also this question. Is it less than 5 millimeter, in between 5 and 12 millimeter? Is it over 12 millimeter up to 20 millimeter? Or is it, as we have seen on our Bystronic Fiber 15 kilowatt machine a few minutes ago, is it over 20 millimeter material thickness? Yes, you can see that also yeah, with this new 15 kilowatt laser, it's also possible to cut really thick material, but also regarding process speed and productivity, for sure the 15 kilowatt laser is a good solution. So also we can see that most of you really cut parts between 5 and 12 millimeter. And also for you in this range, it's very beneficial to have here high laser power to reach high productivity in the process.
I just want to highlight again that especially in this range, from 5, let's say, up to 20, you get the most out of the 15 kilowatt. So especially in thicker material, you get more parts out of the machine. It's about 30% as far as I know. And this is also the range which is also interesting for the Bystronic 120. Now, of course, as I told you, thin material and with high tolerances, I think we are well known for this as well, but especially also thick materials and on a short bending length, many customers are requesting this. We have seen this at the launch of the Expert 40. With the first machines coming into the market, customers have been asking, or can we have a little bit more tonnage, please? This was the reason we launched shortly after this the Expert 80. And again, we launched the Expert 80, and then customers have been asking, oh, can we have something a little bit longer again, and just with a little bit more tonnage again to bend more thicker material, or for example, high tensile strength material.
Yeah, always good to see that we not just cover with our laser different thicknesses of material, also with our bending portfolio we can cover all these parts, especially in the range of 5 to 12 millimeter. We have here yeah, several machines. We will also see them later on to cover yeah, these applications also on your side. And this is exactly now the point. We want to hand over now to our colleagues again to introduce now our yeah, bending portfolio to you, including software.
From cutting, we are going straight to the combination of all processes in our software. Therefore and more is our plant manager. You know him already. Benjamin, it's your turn again.
Almost every company nowadays has an ERP system. How do I get the production order data to the machine and to the customer within a very short time? I will now show you a short presentation. Imagine your sheet metal production as followed. For example, you have a laser system with automation, a small storage tower behind it, a clearing area, and a bending machine automated. The entire production order, from quotation to shipping and invoicing, is managed in your ERP system. You receive the parts from your construction or as 2D or 3D data from your customer. The NC program for your machine are generated in the production planning and programming department. At the beginning, the customer's production order is created in your ERP system. All other data is thus already generated in digital form. At the same time, CAD data are also designed or made available, and these must now be transferred to work preparation. Most of the time, it looks like this. This is a picture from our own work preparation before we worked with the Plant Manager module. Order papers are printed out, and the programmers have to import these 2D or 3D data individually into the Bysoft 7 software. This is where the Plant Manager comes into play. The Plant Manager is a module of Bysoft 7 which combines the order between the ERP system and the production. By using an XML interface, all production order data and also the CAD data can be automatically transferred to Bysoft 7. This means that the parts list with article number and material quality, as well as the number of pieces and the end date, are linked with the correct CAD data and automatically imported into the Plant Manager. Repeated parts are recognized and new parts are automatically imported into the software using the Auto Parts module shown before. The Plant Manager can now use the entire order backlog of the ERP system for his planning. The software knows all laser and bending machines. It knows exactly how much capacity is available per machine, and it knows which material and which order can be produced on which machines. In addition, it knows the exact date when the components have to be cut and bent. Thus, all information is known to be automatically generated in order to plan perfect jobs for the individual machines. At this point in time, the required raw material can be reported back to the ERP system. This helps the purchasing department for planning. The jobs are now sent to the laser and the bending machine, which the operator already sees in the optimal order in the controls job list. The jobs are sent to the machine in such a way that setup and non-productive times are as short as possible. If the job has been cut or bent, the machine automatically reports the production data back to your ERP system. This gives you the perfect basis for an order recalculation. The machine reports back the actual material consumption, including the waste. You can thus trigger a raw material posting in the ERP system. The ERP system receives the affecting cutting and bending time, including waiting and stopping times, in order to book these on the order. The Plant Manager has the part removal model for quality control and for reporting rejects. A screen is made available to the operator in the clearing area, on which the cutting plan is displayed visually. He can thus quickly and easily sort the cutting plan on pallets based on orders or other criteria. With the Plant Manager, You can digitize the entire process flow and no longer have to manually book the individual process. Now we are going to have a look how the plant manager looks like. Let's assume my customer ordered the parts and I want to manufacture them. The plant manager runs as a service and is installed on your server. So he works 24 hours a day, 7 days a week. If a production order is now created in the ERP system, it can be imported automatically. In this view, I can now manage my orders. Open orders can be processed immediately. Incomplete ones require further information from the operator. My current orders are also clearly displayed. In my example, I have a Bystar and Bysmart fiber with different laser powers. There are also 2 bending machines, 1 expert per 250 tons and 1 expert per 320 tons, each in 4 meters. The software now automatically generates laser jobs for the machines. How does this work? I'll show you by using the job assistant. All parts to be manufactured are now sorted according to material quality. For example, I choose 1 mm stainless steel. The plant manager knows the available raw material sheets and also the residual sheets. These are selected automatically. Perfect nesting plans are now generated for the respective material and the respective machine. Residual sheets are automatically engraved and saved in the administration. All of these jobs are automatically scheduled in the calendar. The bending jobs are also generated with a job assistant. All bending programs are planned in the perfect order on the machine. You already know the module. It is the tool setup optimizer, which is executed automatically in the background and guarantees you an optimal bending sequence on the machine. Thus, all machines are perfectly programmed. To remove parts from the laser machine, the part removal module is available. In the part removal program, the cutting plan is shown in color according to the order number or according to individual adjustable categorization, such as the customer or a subsequent work step. With this information, your machine operator clears the cutted plan in the shortest possible time and sorts them onto the correct pallets with little effort. In addition, batch tracking and residual sheet management can be maintained via this module. You see, the Plant Manager is the optimal support for your process planning and your programming department. Orders can be sent from the ERP system to the machines in a paperless and process-reliable manner within a very short time. In this way, you not only optimize the interfaces, but also your entire production process. Please do not hesitate to contact us for an individual offer and presentation. Thank you very much and see you next time.
Good job, Benjamin. Let's continue with our bending technology for highest demand on process speed and flexibility. Our flagship, the Expert Pro, highlighted by the dynamic crowning and our laser angle measuring system presented by Ronny.
Thank you, Sarah. Hello and welcome from my side. My name is Ronny. I like to explain a little bit the Expert Pro, especially the crowning and the lamps system. Let me just a little bit explain about this. First of all, before we bend the part for the crowning, someone know about this. I explained this a little bit later. I explained a little bit how you can program a part onto control. You have seen the offline software Bystronic 7. Of course, we can program the machine over this, and we can also use the control to program a part. We go to new geometry, and then we can start to program the bend part. Let me say, like a part like this, we have 5 bends. This is really simple. We have the left side to draw something, and we have also the right side of the screen. We can type in some main information about the material, about the thickness, and the tools, of course. A little bit explaining from top to bottom. Of course, here is the selection of the material. Then we have the material thickness. If you type in, let me say, 1 millimeter, we get also a selection of the tool. You can adjust this. You like the best tool for you. If I change back to 5 millimeter, this material is 5 millimeter. Then we define the tools P7 and the B40. If you like to change, of course, you can change it here in the list. And maybe for the operator, they are like more the graphical view. You have also the graphical view for top tool and bottom tool. Okay, now we have the main information. Of course, the bending length we have to adjust. This is more or less the right one. Let me type in the exact bend length. And then we can program the part or draw the part. We start on one point, and then we can slide with the finger over the screen to adjust the bend length, of course. You can also type your part like this, 1, 2, 3, 4, 5 bends. And we have also a table or list view, and you can adjust your part also over this. You see we have every time 50 millimeter bend length. This I have drawn 40, and here we go also to 50, and the last one is 50. Then we have our part. This looks like this. If it's necessary, you can open the properties field. In the section you see also the blank size. Sometimes necessary to check is the blank part the right one, what you like to bend. If you go to by vision bending back, we simply just press the produce button. This is this little wheels on top, and the software goes in the produce area and calculate automatically the right bending sequence. Of course, I need some tools for the part. You see there are some tools, but I need a little bit more tools. We can go to the tool setup plan and adjust the tools or place the tools manually. On this machine we have the tool changer. We can also use the tool changer. I switch just to the software from the tool changer. You see the green tools are the tools we need, and the blue one are the tools that are already in the machine from the job before. We simply press the start button, and then the machine change the tools. In this time, the robot changed the tools. We will later a little bit more explain about the tool changer. I would like a little bit more explain the bend part. For this part, we will bend this part. You have seen I have programmed the bend length for 1 meter or a little bit more. But in this part we have some holes inside that we can a little bit more explain what means dynamic crowning. Dynamic crowning means that we are measuring during the bending process what has happened during the bending. Did we need really the calculated force, or did we use a little bit more or a little bit less in our case? And in this time the software or the machine adjusts automatically the pressing force and also the crowning system. We have some additional compensation systems inside the machine. We have also some compensation for the side frame, of course, and temperature compensation. Maybe we can look later on this information, and then you see what the machine doing during the bending process. In our case, we will just look in the first time for the crowning. Of course, the crowning is necessary to have a straight bend over the whole length on the machine, and also that you have the same bend angle in the middle and also on the right side and on the left side on the machine. Okay, the robot is finished. We will go back to the produce area. Let me switch on the compensation area and the crowning. This one. Here you see also what the machine do during the bending process. First of all, that you see that the machine adjusts something. I will bend just a small part, this little shape. I place this on the tools, and we do the first bend just with this little part. This is to check that the angle are correct on every step we bend. Later on, and you can also see on the screen on the instrument that we don't need so much crowning for this small part. Okay, first of all, of course, the safety system moving down to the right position of the tool. Now everything's okay. The safety system is green. This means I can move the machine in fast speed down. Then we do the bend. And let me place the small part here on the side. Later on we need this again, and then I bend this part. You see, I go to the first step back. Of course I have to bend all the bends. And we start with the part with the holes inside. And then if you have a look for every bend on the control, you see that for every bend we get more and more crowning. So during the bend we are measuring the real force on the left side and on the right side on the machine, and in this time we are in real time adjusting the crowning system and also compensate the side frame deflection. So now we are on the middle of the part. The second, last two bends, we have more and more material, and then you see that we need more of the crowning. Now we get the last bend, and this is the most crowning we need for this material. And then we are finished. Okay, let me place the part here on the side that you see it. I remove it. So this is the part. The first bend we did was this, and this is the last one. And you can remember I bent the first little part. This is this one. And if I place this here on my part, then you see this is exactly the same angle. There's not wobbling or whatever. The angle is on every place on the part, of course, the same one. Why we are adjusting during the bending sequence the crowning and also the side frame deflection. Let me go fast back to this compensation side. We can also look for all these values. We are adjusting automatically during the bend. You see the first bend, second bend. On the blue sign, you can a little bit see what was the middle value of this system. This is for the crowning, the last bend, and let me go switch to the compensation of the side frame. You can look here or here. This is in millimeters. You see the side frame deflection. This is the last bend, and I go back to the first bend. You see the first bend was very less material, and we have less of this compensation. We have also a temperature compensation. This is very less. The machine is not so hot today. We have also a system that are stopping the hydraulic if I don't need the hydraulic. And this is how the software or how the machine working with the dynamic crowning. Okay, now we have a straight bend line over the whole length. The next point is if I need the right angle in the first time, then we can also use the LAMS system. Let me show this on another part. This looks like this. Of course, we have to change the tools again, remove and start. And the robot will do this from behind. And I can explain a little bit this part. The plank part looks like this. We have different bends on this part. Of course, we have also some holes. This could be a little bit difficult for the LAMS system. Of course, this is a laser-based measuring device, and if you have some holes, then you have to look that you don't measure on the holes. If the holes are like this, a little bit smaller, then it's not a big problem, but for the bigger holes, of course, you have to look. Otherwise, the length we need to measure exact angle is around about 15 millimeter. And you can say, also say, we can measure on one side of the part, and on the other side, if you have the same angle or you cannot measure, you will see it on this part. We have two bends we cannot really measure. You can also take over the correction values from a bend before. And there's also two different modes. Of course, you program your material thickness and your material style or your material, like steel, stainless steel, or whatever. And then you can say, okay, I take some values from the database, especially springback values. This is the normal mode we are using the system. If you are not really sure what kind of material you have, or maybe the variation of your material is a little bit bigger, then it's also possible to measure the springback of the material. These are two types. Let me show this in this part. First of all, we move the backstops on the right position. The safety system moves down. You have seen this before. And then we can do the bend. For the bend itself, you don't need to do anything. You just switch on the system. The measuring device are also not slow down the machine. You see the speed is more or less the same. I hold the part like this. You see these two bends we can measure, and the next two bends are the part is very close on the table. And for this we cannot really measure, and in this case I just take over the measured value from the bend before and do the same correction. Like this, and this one is the same. Then for the next bend, this is 90-degree bend. Let me look on the control how I have to hold the part in the right way. Of course, we can measure again in front and back. And for the second bend, normally I could also measure, but in this case I take over the value from the first bend. Then you don't need to use it for every bend, and the last bend is a little bit different. I explained it before. Just in case you say maybe the material could be very difficult, or you have a special material and you like to measure the spring back, then we can also use this in this mode. This means the machine do the bend. You will see it from the side. Then we release a little bit the material, measuring the spring back, and re-hit in one step and do the correction, and then we are finished. Then we have our finished part, first part, the good part. Okay, this is from my side. I will give back to Sebastian for the next topic. Thank you.
Thanks to you, Ronnie, for these impressive insights. And we have more awesome news, especially about our laser angle measuring system. Carsten will tell us more about this.
Okay, thank you, Ronnie. You have seen just a number of nice, interesting features. I think now we have one of the fastest tool changers in the world, and I think we will come to this later more in detail about the tool changer. What we have seen as well, what Ronnie mentioned, was the fast bend safety system. This is motorized. That's a very important system. For example, when you have a tool changer, to increase the speed of the tool changing process. Remember the movie or what you have seen from Benjamin just a second ago in this, what he have told you about this tool changing time, and you have seen that these tool changing sequences, they make most of the time at the moment. It seems like this in the bending process, and that's the idea that you have, for example, a tool changer, and this can speed you up. We have a number of other features, as I mentioned, fast bend, the safety system, and also optical bend guiding system. We didn't mention this so much. That's the system which is indicating you on which position you need to set up your tool. Of course, the tool changer is making this automatically. Then you just see the next station. When you bend, then afterwards you are guided in the bending process. That's the idea of this. Now about lamps. Lamps you have seen downstairs. This is generation number 4. This machine is already old. It's from 2020. This will come out in the next 2 weeks, and the new tool changer with all the new features will come in. This means this will be a lamps generation number 5, but we don't speak about the different generations, but it's again different. What is different about laser angle measuring system in the next generation? At the end, this laser angle measuring system is an optical system, and when you look at all optical systems like on your mobile phone, there you have a camera, for example, and doesn't matter what mobile phone you have, and you get the next generation, you have a better camera inside, and this camera helps you to make better pictures in the night, and so on. And here, it's not different. No? We have an optical system on site. It's a camera-based system. This is working much faster. The cycle time is getting much faster with this optical laser-based system. But it's also much more flexible, this system. So because the new generation will be able to cover a range from a V4, so for example for material thicknesses from less than 1 millimeters, and then up to V300. That's a material thickness of about 20 millimeters. So that's really, really flexible, this new system for a bright range of different materials you can use on your machine. So this will come soon, and you can look forward what's coming in the spring from Bystronic, what is coming new. You should make a note for the competence days in Switzerland. This will be in June in Switzerland, and there, for example, we will present this new highlights to you. What's also interesting, we've got already the first booking for a live demonstration. So feel free, as we mentioned to you before, you can book now your live demonstration on our booking tool, and yeah, we can do this more or less straight afterwards. So with this, I hand over to Benedikt.
Yes, one additional comment to the modular tool changer. There was also a question in the chat, and we said we will answer your questions today. regarding the safety on the modular tool changer. There was the question if there's a possibility that an operator get in touch with the robot during the tool changing process. This is not possible. We have 2 light barriers in front of the machine to protect your operators then during the tool changing process. But they are not very space consuming, so that you also have the possibility to store your material already in front of the machine and at the same time protect also your operators. But Carsten, we also received more questions into our chat. And one of these questions was, how can you bend 8 millimeter on 2 meter with 120 ton machine?
That's a good question from your side. That's something I hope you have seen also this in the demonstration from Ronnie. So when you program a new part on your control, for example, then the control is looking in the tools and is choosing the right tool to bend this part, for example. It's the same when you get a 3D part, then our software is also choosing automatically the right tooling for this. And the same, it's with the bend solver. We have the app available, for example, in the App Store, and there you can download this application, and with this you can calculate easily what material thickness you can bend with what tooling combination and with what tonnage you need. So this is possible. What you can do also is you can have a look in our website. There you find also the material, how we can calculate the combinations of tooling and what tonnage you need to bend the material. So all this is available, and you find this in the different tools we have available. We can do this also together, as I mentioned in a live demonstration later on, especially when we launch the machine. So look or watch Bystronic from the middle of the year. You can expect something, and then we can bend something with you together. So with this, I have one question for you, Benedict. Which is more difficult to cut, mild steel or stainless steel?
We can say it's stainless steel, especially regarding the beard you have in the cutting process, but also regarding having a beard on the material in the cutting process. There is also a feature, especially for mild steel parts, the beam shaper. If you cut the part with oxygen, we have the beam shaper as a feature on our Bystar fiber, and then you can avoid this beard on your material. So we also have features and solutions to avoid these in the cutting process. And there was one additional question. This is also related then to the thickness of the material we can cut. We showed you today a 30 millimeter, but Carsten, what is the maximum we can cut on this Bystar fiber 15K?
I think there are at the end no limits, but at the moment the official answer is 50 millimeters. But you can expect that there is coming something more in the future from Bystronic. As far as I know, there are rumors that there are even lasers will come up with much bigger capacity from a kilowatt to make it possible to cut thicker material faster. At the end, that's what you do, no? You cut it faster. And that's something what you can see on different exhibitions, or what you have seen on different exhibitions as well. And again, we can just ask you to come to a live individual demonstration with us. Book your demo with us online, and then we can do this. Doesn't matter if we have Corona or not, we can do this live with you. So with this,
we are straight on the way to go deeper into automation. We have seen already our modular tool changer in combination with our Expert Pro. And we have seen that the process is always a big topic. So automation can shorten your processes, and for this reason we want to ask also then a further Slido question to you. And the question to you is, what is most time consuming in your bending process? So we want to discuss this question today also with you, also regarding our products we show you today. And please feel free to join Slido again. Is it the tool setup time which is most time consuming in your bending process? Is it the correction after you bend a part? Is it the programming of parts, which is also a topic we want to address in a few seconds? Or is it redoing waste parts in your bending process? So please feel free to join also here into this question. And I think we will go deeply into this question also later on. And maybe you want to comment something.
Exactly, I want to highlight this again. That's what Benjamin has been showing us at the beginning. And the good thing is about this, now you can see this again if you want to watch this again about tool setups. That's also the feedback from the people here, that there is the biggest issue at the moment. And also here, getting parts from the laser is interesting, and corrections after the first bend. This is, it's LAMS, laser angle measuring system. That's the idea of this system. We have different systems available. We mentioned the two systems. One is LAMS, laser angle measuring system. This, the idea of this is to make first bend good bend. And we have dynamic crowning. Dynamic crowning is the patent from us. And the idea of this is that you have all bends good. That's then the different philosophies between these two different systems. So first bend, good bend is LAMS, laser angle measuring system. And again, tool setup is the biggest point. That's also what you have maybe realizing there when Ronnie was speaking there. The tool change was happening automatically. I hope your operators don't speak just or drink coffee during the tool change process. So what they can do in this time, they can take new parts, for example, or they can do something what they have to do in the IT to register what they have done so far and everything else. So it's that's something about the tool changing process. But we mentioned tool changing, we come to this later, and I just want to highlight again, and that's also for your individual demonstration. We have also other systems available to increase the tool changing process. One is, for example, optical bend guiding system. As I told you, that's the little LEDs which indicate you the right station to set up. New is now on our machines that this is also available in the table, so you are much faster now with your tool setup for stations, for example. Sometimes the station plan is also different from upper tools and lower tools, and this is also indicated by this system. And the fast bend safety system as well. It's moving to the right tool height, and even if you have no tool changer, very often mistakes have happened in the past that the wrong tooling was in, and then you have a crash, and when you have a worst case, you have an accident of an operator. And with our systems, fast bend safety, we have this now since 10 years in the market. It's a motorized system which goes to the right height of the tooling, and it's double checking if the right tooling is in. So even when you have a manual tool changing process, this speeds you up and gives you additional safety.
Yes, we can see in the answer that the setup time in general is a big topic. So how is the whole process? In the next few seconds, we will also show you more of our bending automation products. And also for this, software is a topic, especially for the setup time of a part in an automated bending process. And with these words, I want to overhand to my colleagues downstairs who will introduce our new and next demonstrations. Have fun.
So, what we have seen so far. Let's sum up the latest Bystronic technologies. There is the Byster fiber 15 kilowatt with a 30 millimeter of cutting, our upcoming mid-size press brake, the B-Bend Star, and our bending flagship, the Expert Pro.
These are crazy and amazing developments. As you can see, Bystronic is a company which is always expanding its product line. Just the best choice.
That's right, Sebastian. But nevertheless, we have one more thing for you guys. We saw cutting, we saw bending, but there's one more left. Automation.
One of our best-known faces of Bystronic, Garrett Garrettson, will show you how easy and fast we can program a part in our Robot Manager. The Robot Manager is our software for our automated bending machines. And because this is an international event, we switch directly to Switzerland, where Garrett is.
Good morning. I'll show you how to program a part on our new Robot Manager. This is a software we developed to program our robot cells, and it's extremely easy. Right here you see the main page. I can open parts, that's what I'm going to do. These are the parts I used last. These are already projects which exist. And here I have my customer database where I can find parts which I want to robotize. So I take this one here. Here I choose my cell. I know that I have this cell, choose that one. And now we get to the main page of the robot program. And here we have to choose, for example, the cell, the grippers and everything. I can check my part again, double check it. All right, this is the cell. So I see my pickup pallets here, I see my chute, I see the machine. I can switch different things on and off. Yeah, normally I want it like this. This is the easiest to program. So what I need to do here is to choose a gripper or a vacuum cup. That's what I did, and then I make a program. So that's what it does here. I can verify all this. I don't want to do the dual sheet detection. I know that my parts don't stick, so I'm fine. Create a program, and it will now make blocks. For this program, I need 2 blocks for the bending. They're right here at the bottom, and then home position, pickup, that's where I am now, reference, and drop it in the chute. So this is where we are, and this first bit is about the part itself. So I need to tell the machine where the part is. So I say, yeah, it's here, it's fine. Next position. What we've tried is to use as least possible this side here where the numbers are. I don't want to type numbers. I hate numbers. So here, this is the reference table. Parts should drop in this corner. So what I do is I let it drop. We calculate. We have a physics engine in here. Friction, gravity, inclination, and it drops right here in the corner. So we're good. Last bit here is how am I going to let it drop in the chute here. Chute like this. Maybe put it in a little bit more. A little bit more. There, that will drop, no problem. And once I've done that, I'm finished here. There's no more black arrows. So next one is the gripper positions. I need to do the same thing again. And what we've done here, something very clever. I have a before and after view. So if I make a movement here, I can see the result of that movement here. So if I make this movement too big, then it results in a crash here. I don't want that, so put it back. Normally what we calculate is pretty good. You don't need to touch it. So next position, from here to here, that's fine. And then first bend, second bend, and then drop it. Again, if I want to move something, I can move it, no problem at all. Put it back. And again, also here, of course, if I touch something, it will get red, and that's basically a bad idea. I leave it like this, so that's basically it. At the bottom, everything is yellow. That means that I've done it, and now I need to create the robot program. So first I hit this optimize configuration. Now the software tries to eliminate unnecessary movement. It's done that already, and then check. Now it's connecting all these blocks together, and if there's a collision between blocks, like I have here, it's red. This is red, there's a collision. Also these little dots indicate the collision, so if I go there, then I can actually see the collision. It will go through this thing here. That is not a good thing. But we've noticed that there is this collision, so we've already done the next step. We've created these 2 blocks in between the other blocks. So here, these 2 red blocks are points in space, which have not been calculated yet. But if I push this button, it's calculating. So we add points in space, and now I have a complete collision-free robot program. So this is it. This is done. What I can do now to make more autonomy in the cell, for example, I can make a stack pattern. Here I can say copy this one in the Y direction. So I've got 2 now. I can enter my pins. I want a pin here. I want a pin here. This is for the operator, to shift his parts against. One here, and I see that this one is red now, so I need to move it a little bit more like this. That's okay. And then I can do the same thing for the place position. That's here. Again, I can just say copy this one, copy it once more, like that. Yeah, fine. So I don't get a big pile in the end of my pallet. I get a nice 3 little piles. That's much better. I need to calculate these parts because I've added positions. So I hit check again. So it will recalculate everything. The middle bit, it will stay the same because I didn't change that. And now I have new positions. Everything's green. The pickup positions are here, and these are the chute positions. And everything is done now. I can run this. I can choose here which one I want to see. This is the first one. Reference position here. It's the middle one. So let's simulate this. We choose the views automatically, so the operator can see exactly where the movements are. This is happening 100% in real time in the cell also. You can block the view with these little buttons here. So now our program will keep this view until the end of the simulation. I will unblock it because otherwise we can't see where it drops the part. So bend number 1, bend number 2. So I wasn't talking, then making a program like this will take 2 minutes, 3 minutes maximum. Of course, if it gets a little bit more complex, I'll need a little bit more time, but it's still super easy to make programs with Robot Manager. I'll unblock this again, and then it will put it on the output here, and then it will go back to the home position. So that's it. I need to save this part. I need to export it to the machines. That's what I do here. Save, and then here, and it will also make a drawing with where the operator has to put these pins, the pins for the table, so he can put them in the right position. And that's it. I'm all done now. Another little feature in our Robot Manager. Of course, when you do some automated production, you need stacks to pick your parts up, and it would be nice if you could have stacks also to lay your parts down. And that's what I'm going to show you here on the Robot Manager. So I've done the part. It's the same as before. I've changed the cell. So now I've got an 80-ton, 1.50 meters, and I've got this conveyor to show you better what I'm going to do. So this is all green like before. And then we have to go to the stack pattern. Stack pattern, here I see my pickup place. And the easiest thing to do would just go here and say copy, duplicate, and then it made another stack. That's easy, make one more. There, I've got 3 stacks already. And then I can also duplicate everything here to another pallet. This is the other pallet, duplicate here. So now I've got already 6 stacks, so this can run for hours and hours. I'm going to take them away again and show you some more details. Here, pallet 41, that's this one here. Also this one here. Let's leave these 2 stacks because it's not done with only the stacks. I need to put these pins in. I need to reference the parts. So I'll put a pin in here and I'll put a pin in here. So this is fine. You can push your part against this pin and then it's referenced. And the same thing, I'll put a pin here. It's there already. And one here. So if I would duplicate the stack now, it also duplicates the pins, of course. What's happening, we're checking collision with these pins. Of course, first of all, the parts against the pins, but also the robot against the pins. If you put everything full of pins here, the robot cannot get to the last sheets on this stack anymore. Also, we simulate and we make the program in the way you've put the stacks down. So this is the first one, second one, third one. You cannot start here in this corner because everything would be full with parts. It doesn't work. So this is okay. Then again, you can still see that there is a little bit of space here. That doesn't really matter, you know. The moment you touch the pins, it gets red. But it doesn't need to be that precise. If you're within, let's say, 5 millimeters here, that's good enough. You know, you don't need to make really precise, super neat stacks. They're going in the reference table anyway, so you're good. We also have customers who just put this stack against this one, so they save pins and of course they save space also. So this is the pickup stack, and then we go to this stack here, the place stack. One part already. And again here, I'm just going to copy it. There, I've got a second one. And then I'm going to put a third one on top of it. And since we don't have an automatic function for that, I need to move the part up a bit, move it over, and then maybe twist it a bit like that. And this is my output stack. So very easy to do that, no problem at all. And then what I still need to do is, of course, make the program for all these things, because I've actually made now 1, 2, different programs here and 3 different programs here. So I go back to paths. Here we see it's like a little railroad. So this is the original one, and these are the ones I added. Also here I see the other references, and here I see 3 place stacks. So I run check again. It's going to simulate everything again. Once this is green, maybe it's not all green, maybe I need to change 1 or 2 positions. It's all green, great. So if I want to see that last, this one here, the second stack, yeah, and then I can simulate it, and you will see here at the beginning that we will pick up from here. So it's already made the program. I'm just showing you the simulation. So running through, referencing, and it's going to do the 2 bends. So I've actually made now 5 little different programs. You can use up to 4 different parts in our cell, the little cell. So you can have 4 different parts on these 2 pallets, and the moment your tools are okay, you can swap between parts automatically. We make a job list, and you can swap from one job to the other automatically. So you can have yeah, like 8 hours run in that cell, no problem at all. It is already the last bend, and then it's going to put the part on the conveyor there where I put it. This is the second place. And there we are, program done, everything done, we're good to go. Thank you.
Thank you, Garrett, and grüezi to the wonderful Switzerland. From the robot manager, we go straightly to Eric. He will show you how one operator can handle 3 machines at the same time.
We are starting with the bending cell for fully automated tool changing and bending process.
At the same time, Eric will also show you the most flexible automation for fast and precise tool changing, our modular tool changer.
And last but not least, there is enough time for our powerful mobile bending automation in its most flexible form. The mobile bending cell with Expert 40 and conveyor belt. Eric, go for it.
Yeah, again, welcome from my side. We are now in front of our bending cell, the big bending cell. And first of all, we will make a little walkthrough through the machine to show you all the main and key features of the machine quite quick. So we will start inside here with our pickup position. So we have 2 steel pickup pellets with these pins. You will see later on the mobile bending robot also for pick up your parts. In our setup, the pallets are here, but we are also quite flexible with the layout of this machine, so you can have them also at the other side or whatever you need them, or wherever you need to fill up your parts. We have here attached a separation magnet for separate the parts to make sure that we only have one attached to the gripper. Then we have our alignment station here to align the parts, and this is also equipped with the double sheet detection to detect the perfect part and that we don't have 2 parts stick together. That's the check for it. Then we go a little bit around to the machine. We have an Expert Pro 150 ton by 3 meter machine attached to this bending cell, but we are also able to have the fully ranged of the of the Expert Pro machines in our bending cell. So you can have a 100 ton or up to 320 ton machine, and you can have a 3 meter machine or a 4 meter machine. This bending cell is at the moment sold to a customer, so we will replace this to a 4 meter machine in the next time. So feel free to book also a demonstration for a 4 meter machine. The bending cell can also equipped with the laser angle measuring system to make sure that we have constant angles over the whole bending length, over the whole process. The machine is equipped with contact fingers to check if the robot is perfectly at the position. And we have an extended version here in our case. So when we go a little bit more in the back, we have our regrip station. The regrip station is attached with 2 arms, so we have 2 movable arms. They can move together to regrip your part, and we can use for this 4 suction cups, 2 in the top, 2 in the bottom, and we can have 3 clamp grippers we can move in any position we need for regrip your part. Also, we use the regrip station for turn your tools, the upper tools that we also can put in rotated gooseneck tools. So we are easy and simple to rotate them also. If we go more in the back here, we have our tool cabinet with various tools. So we can have V6S up to V120 also with the big bending cell, and also a various range of upper tools. When we go more in this position, we see 6 set-down pallets. In this case, we have also a customer part we will pick up from one of the set-down pallets or the set-down row and put it next to them. And next to this, we also have our gripper trays. So we have 5 various grippers attached, or can put them into the machine, but one of the trays are reserved for our tool change gripper, because the bending cell can also automatically change the tools. Some words to the robot. We can have a robot from 90 kilogram handling weight up to 270 kilograms. So we have various robots in between to make sure that we have the perfect one for your parts. So, and with this we will close the cell and start the first job, and then we can go to the next machine. So the robot will start now to product the part. So we go to the pickup position, pick up the first part, bring it to the alignment station. The back edges will position to the perfect place. Double sheet detection is done, and then we go to the first bend. In this time we reorientate the gripper, but we are also able to use the following function to follow the gripper with the sheet during the bending process if you have like further bigger parts. So next bend. Attach it and bring it to the set down position for set down the part. And now we let the cell run and go to the modular tool changer. So maybe you had seen the modular tool changer a couple of seconds before at the presentation from my colleague Ronnie. He used it also for his part, because we are in the most of the time quite efficient operators to look for our back, to make sure that we don't have to handle so heavy tools the whole day. So that's the reason why we try every time to use the modular tool changer. I will just say some words about it. What is new with this machine is smart segmentation or smart routing. So we can also shift tools during the changing process, which makes the tool changing process really quick, really efficiently, and yeah, we save in this case time. And with this, we will start the tool changer to make sure that we can change the tools, and then we can start to bend here the first tools, and in this time the tool changer will change the tools. I will go to the mobile bending robot. So I will start up the program. We have equipped this this mobile bending cell with Expert 40 in the back. We have a robot which can handle tools which can handle parts up to 10 kilograms with a maximum size of 300 by 600 millimeters. And we have attached a conveyor belt to set down the parts properly and feed them out using an automated conveyor belt. We can have also this mobile bending robot with the Expert 80, so 80 tons by 1.5 meter. But we have now, in this case, attached an Expert 40. So again, we have two pickup pallets, steel pallets with the pins in it. We have an alignment station to align the parts. We have a regrip station with 4 suction cups and a clamp gripper. And we can easily change the tools by hand using our RFA clamping or the XPT clamping with this machine. If you need further information to one of these 3 machines, make sure that you book a demo using our landing page. And now we can let the machines run a little bit through the whole time. They can produce, and I can go and have a coffee together with my colleagues. So all machines were working now, and we are good to go on with Sarah, and we let the machines run some seconds more. Okay, back to Sarah.
Well done, Eric. Our expert, Benedict, will tell you more about automation now.
Yeah, welcome back here from our side. In between the demonstration for our bending automation portfolio, we received also questions from you in the chat. One question is when we expect to improve our service department from Bystronic so that the service technicians also have the knowledge regarding the Intel equipment, so that you thought that the factories do not talk to each other. That's a very good question. Carsten, maybe you want to answer this question?
Exactly, that's really a good question, and I just can mention, for example, automation. When you look at this demo center, and some of you maybe know us a little bit longer, if you have been seeing this 5 years ago, there was no automation at all for bending, for example, no at all. We started into the bending automation process 5 years ago. We have taken over a company, and we have been trying our best to teach our technicians worldwide as fast as possible and to build up. For example, this year we have a big initiative from Bystronic. That's something you will hear also from our service departments worldwide. We are going to add our service team 100 more people. So 100 more people, that's a huge step. For this, we have to train all of them. And I'm sure I agree with you that sometimes for you then interesting or strange, but we need to build up, and we try really to build up and as fast as possible. What I can say just is we are just human, huh? And we try our best to go to the point and to reach our targets and to give you the best service in the world what we have been promising when we have been selling you the products. And you can take my word that we try our best always. With this, I have one more question for Benedict. How the robot gives a signal to the bending machine?
Yeah, that's also a good question. So Eric mentioned this before. We have contact fingers, so on the baggage mounted to have the communication between the robot and the bending machine. This is the most common way to detect when the part is really put on the baggage system to achieve the accuracy into the process. And this is also then at the same time the communication between press brake and bending robot. It's also possible to make bends without this contact, but in the end, to reach the quality and the accuracy regarding bending flange length of your parts, it's always recommended to use these baggage systems into the bending process, and then also the communication is done. Several other questions came in between. Back to the laser angle measuring system, Carsten. There's a question. Once the LAMS performs the first angle correction, does it remember this correction for the further bends? So to speed up the further process then also with an angle measuring system and correction?
Exactly. There are 3 points I would like to mention. First point is this. Please feel free to book a live demonstration with us with your own parts, also with LAMPs. That's always the easiest to find this out. And there are 2 more points. One is, of course, you or the LAMPs is taking this value for the next bend. And you can do this, for example, also when it's not possible to bend or to measure at the next bend, this value can be taken. And then one more point I would like to highlight. You don't even realize that LAMPs is switched on or switched off. So when you speak about time saving, LAMPs doesn't matter. If it's on or off, it's the same time you need for the bending process. So with this, we're coming back with one more question for the bending automation. When you change between 2 different parts, do you have to take out all the tools, or can you take some tools in? I think you get this question several times per day. So, Benedict.
Yeah, I really often heard this question, and I can answer to you. The robot will not have to do and take out all the tools of the machine. We have integrated here several intelligence. We have integrated several algorithms to speed up the bending process, and we also achieved with this, one of the most flexible bending automation and also tool change systems in the world, in my opinion, because it doesn't matter where you have positioned tools into the tool setup. It doesn't matter if it's on the left or on the right side. You can add tools, you can remove tools, and also the intelligence in the background knows what tools are set up in the machine. And if you have a second job, then these tools are kept and you just bring the new tools. So flexibility to add new tools and remove tools at any position, because we do this with the robot, and also to speed up the process. We reduced the empty runs of the machine, and also to keep tools into the clamping to speed up the tool changing process. So we received here an acceleration of this tool changing process of around 30% compared to bring all tools away and bring new tools. And we also received the customer feedback from customers who have integrated the modular tool changer in their production, that it's really fast with this new intelligent function of the smart routing. So a big benefit then also for you in the process to speed up and higher the productivity. We also have seen in the presentation that one person can run 3 different bending automation systems. I think this is an important point. You and also we received, I think in the last year, many requests regarding bending automation. We never had so many requests in the last year regarding bending automation, because we all know the times are not very easy. Maybe operators are not available all the time, but our customers want to keep their production running. And this is the reason what we also want to show with this demonstration, that automation is really the key to speed up the process and also to have a reliable process, not depending on availability of trained and good operators, or maybe also beside the illness of maybe some operators.
Do you know how many of the small automations we have in the market roundabout?
From the mobile bending cell, I think it's around about 130 machines into the market. I don't know if it's 2 or 3 less or 2 or 3 more now, but it's around 130 systems into the market. And also regarding the modular tool changer, we have several systems in the market, and we also want to show you this with a customer. He also introduce our modular tool changer in the next few seconds. And in this case, back to Sebastian.
Eric also spent time with our customer Kevin Rotauge. He gave us a great and fantastic inside view of his production with the modular tool changer.
Hallo und herzlich willkommen im schönen Speyer. Mein Name ist Kevin Rotauge und ich bin Gründer und Geschäftsführer von Rotauge Schneidtechnik. Ich begrüße Bystronic heute bei mir im Haus. Noch ein kurzes Statement zu mir. Wir sind Lohnfertiger im Bereich Laserkannteile. Wir sind etwa 10 Mitarbeiter und wir haben uns darauf spezialisiert, gemeinsam in die Zukunft zu schauen und eine Smart Factory aufzubauen. Dafür haben wir unseren Partner heute Bystronic im Haus und wir stellen euch den MTC vor. Ich wünsche euch viel Spaß.
Yeah, welcome everybody. Here now from a little bit different location. We are at customer site in the beautiful town of Speyer at the customer Rotauge Schneidtechnik, and we are in front of an Expert Pro 320 ton by 4 meter as modular tool changer. So you can have the modular tool changer in the range of 100 tons to 320 tons and also from 3 to 4 meter bending length. So some words about the general features of that machine. This machine is equipped as 320 tons by 4 meter. We have arranged a T12 table here, which is a bit wider table for handling also lower tools up to V120. We have an RFA upper tool clamping here for handle our tools fully automatically with the modular tool changer. Then we have equipped the machine with the optical bend guiding system in the upper tool clamping, which guides your operator through the bending steps in your bending process. It shows you the position of the back edges. It shows you your pressing force, and also it shows you where you have to set up your tools. And new for this machine type, for all experts now, is the optical bend guiding system in the table. So you also have the possibility to see where you have to put your lower tools into the tool clamping. Basically, the Expert Pro machines are available in 3 speed classes, starting with the Classic Edition, going over the Performance Edition, and on the top side we have the Dynamic Edition, which we have in the back here, so we can handle up to 25 millimeters of bending speed. We have also equipped the safety system for your operators to keep them safe, which is electrical high adjustment. It calls Fast Bend Plus, so it will every time fit to the correct programmed height of your tools. And also the machine is equipped with the laser angle measuring system to make sure that your first bend is a good bend and your first part is a good part, and that you can measure and also correct the angle during the bending process. Okay, what I have forgot, we have a sheet support here, the small one, which can handle up to 150 kilograms. We are able to have 2 on this machine type. In this setup we only have 1, and we have 2 support arms to handle as best as possible for your operator. Yeah, that's basically everything around the machine. Now we go in the backside to see a little bit and talk a little bit about our modular tool changer. So now I want to show you also the inside of the modular tool changer. So what is the biggest thing in here is the robot. We have set up here a KUKA robot which handle the tools using an air nozzle to blow out the lower tool clamping to make sure that there is nothing in it. And it's also for learning in your new tools. So you don't need any technician to load in new tools if you need some more or whatever. So we have basically in this machine 3 tool cabinets to store your tools. We have 2 in the side and 1 in the back, and we are having a tool range or range of toolings from V6S in the lower tools up to V120. And we also have a various range of upper tools like a P5 or P4 or P7 in length of maximum 515 millimeters and a maximum height of 350 millimeters. Yes, and what we see here also, which is basically get it to the machine, are the back edges. So we have a 6-axis back edge system with some little bit bigger and thicker fingers to also make sure if you have like a little bit stronger material that you have enough space to put them against the back edges and have everything correct. What we see also in the top is the turning station of our modular tool changer to rotate tools. So we also can rotate the tools fully automatically using the robot. And now we will go outside again and see how the robot will change the tools. So, and now we had seen the tool changer in the back. We talked about some specs of the tool changer, and now we want to see that the tool changer can also change some tools, and I can relax a little bit. So I just prepared a part, and we switch now in our ByVision robot, which is the control software for our robot. And what we can see in green in the upper section of the software is the tools we want to change in now. It's a P7 and a V80. And to change, we only click on fast change and then start the tool changing process. So the robot will come now in front, and then he will wait some seconds till the tool clamping is completely open, and then he start to change the tools. So as I talked before about the optical bend guiding system, you see now where the robot will put the tools on it in the lower and also in the upper tool clamping. And yeah, in the time I've spoken to you, you see the robot will change the tools, so your operator is able to do some other jobs around the machine, and the machine will automatically bring the tools in. So tool clamping is closed, robot is parked, the job can be started now. We don't want to start the job now, we want to change some tools. So I just swap the job to another one, open it up, and now you can see on the lower position of the screen, you can see the current tool clamping, and on the upper one you see the tool station plan, which is now needed for the next job. For this we also can click on start to start the tool changing process. What is also in the software, quite simple, is an overview about all the tools we have stored in our tool changer. We can have some information about what length we have here. We can see some details about the tools, and we are also able to change really quick the new tools into the robot. So if you need new tools, you don't need like a technician from Bystronic. You are able to do it by your own, so you just hang it in and using the laser sensor to measure in the new tools. And what you had seen also, he just kept the upper tool, the one segment for this job, so we need this for the next one, so he only built up the additional needed tools for this job and keep this segment in place. Okay, so also this job is loaded, tool clamping will be closed now, and robot will park, we can go on to bend. Okay, processing is finished, and for the third job I just take another part for us. So it's a 2mm steel part, we seen here. We go on production mode, and what you can see here is a rotated upper tool. So we are, as I talked before, we are also able to rotate upper tools. That's specially needed when you have like gooseneck tools. Then you will maybe rotate them to give your operator more safety in front of the machine. And for this, we have the turning station I talked before, and we can click on start, so he will remove the old tools and bring in the new ones. So first we will remove everything, and then we will go to the new tools. So last but one. And now we start to bring the new tools. We're working with a V16 as a lower tool, and before the crop one as an upper tool, and this one needs to rotate it. So we're now in the position to rotate everything. Maybe some words about the minimum tool section or minimum tool length we have. In the lower tools we have like 50 millimeters. In the upper tools we can handle also tool segments from 30 millimeters. So one more second for the lower tools. And now the robot will start picking up the tools from the tool shelf, from the back tool shelf at the moment, lift it and bring it automatically to the turning station in the top of the machine. Lay it down there, regrip, reorientate the robot, and then go and grip it from the other side. And when we see now the tool coming into tool clamping, you see it's rotated, so we don't have any issues with the operator, and the gooseneck is now in the back of the machine. So we have two more segments for this. We have a 40 millimeter upper tool segment. We are also able to rotate 550 millimeter segments, so the turning station is really big enough for this. And all tools we have in our range of tools we can handle with the modular tool changer. So one more segment to go. 275 millimeter P4. Again to the turning station. And now with the last change, I say, and I give a special thank you to company Rotauge for the time, and I go back to the studio of Gotha. Thank you very much.
Many thanks for this inside use of our customer, Kevin Rotauge. So let's hand over to our expert, Benedikt, who has some more interesting details for you. Let's go.
Yeah, thank you also from my side to Kevin Rotauge. He has installed, as Eric said, a 320-ton machine with a modular tool changer with a bending length of 4 meters. He also bends smaller material. He's a chop shopper, but he also bends thicker material. For this reason, he needs the tonnage of 320 ton, and especially he then needs heavy tools and big tools. And therefore the modular tool changer is a good solution because we can handle up to these V120 dies and also the large tools with a maximum length of 515 millimeter. To go on here, we want to ask you a further question, and this question is why is automation getting interesting for you? Is it that you want to use a machine during the night? Is it that you have many different jobs with small batch sizes, or many jobs with similar parts? Or maybe is it really the independency, what we talked a few minutes ago from operators and employees? So we can see that many of you want to use a machine during the night, so to extend maybe from 2 shifts to 3 shifts to have a higher productivity in your factory. But we can also see that you have many jobs with small batch sizes, and therefore we have seen solutions like the modular tool changer to speed up here the process, but we also have seen the robot manager programming in combination with our bending automation systems to have here a short setup time also for smaller batch sizes.
That's really common, I think, with this small batch sizes. We have customers which bend about 10 pieces always on the mobile bending cell, and they make also just a program for 10 pieces, and it's not even coming again, this job, and they make it like this. But it's the idea also what you have seen downstairs and what we can show you in a live demonstration, that you have, for example, 4 different jobs which can be done in a job list, each after the other.
Yeah, we are nearly at the end, but we have a few more topics for you. few minutes left, and for this reason, I want to overhand to my colleagues again for our last topics for today.
We have already seen many of Bystronic products and innovations, but Sarah, how we can track them and how we can keep the overview about this?
For sure, the Big Cockpit provides us production data at any time on any devices. So, Luis, please tell us more about this digital service.
Hello, my name is Luis, and I want to tell you something about the digital service from Bystronic. Have you asked yourself how you get live informations of your production to make quality, time, and cost transparent? And you don't have to stand next to the machine. With our 30 years industry know-how, we developed an application which runs on every mobile device, iPhones, laptops, tablets, where you have the opportunity to retrieve information everywhere and 24/7. Today I want to show you the Bystronic app, Cockpit. In the tab Factory, you have a complete overview about your complete production line, about your lasers, bending machines, and to compare availability and capacity. In cooperation with the module Plant Manager and the tab Planning, you have a status about your new orders, about the capacity of cutting, bending, and also critical orders, and if you are on time with your production. In the tab Laser, you have the status of your laser machines to predict and prevent issues and reach the highest level of availability. You have the running hours of it. You have the overall equipment effectiveness. And in the diagram staff and block, you can see if the machine is waiting for material or the machine is waiting for a user input. From the laser overview, you can break down to each single laser machine with a video stream and also the status of each machine. In the tab Banding, we also have the banding overview. We have the performance of all banding machines and the time between the different bands. From the overview, we can break down again to the single banding machines and have all diagrams. You have over 25 KPIs, and in the tab Storage, in combination with the Plant Manager, you have the value of your storage, the material rate, and the range. And all in all, you have the messenger service to have everything and directly on your mobile device.
During our Digital Technology Day, you guys had a chance to ask us any question via YouTube and Slido.
And our experts, Carsten and Benedikt, will of course take the time to answer as many as possible.
Yeah, welcome back. Very interesting to see here in our poll that automation is not anymore for jobs just with similar parts and of high of batch sizes. Also, solutions are requested for small batch sizes and also machines which can run during a night shift fully automated. So we see that this changes a little bit. Very interesting also to see this for us. Automation is not just for big batch sizes. It really is a good partner also for smaller batch sizes and also for job shoppers who run many different jobs. This is nice to see, and we have solutions like a modular tool changer and also our programming software, which makes it easy to handle then also smaller batch sizes on an automated system.
So with this, we come to the next question, and the final question for you also in Slido. It's about the cockpit, and it's about what is the most important information you can get out of this cockpit. Is it the statistics of parts? That's interesting. You can compare, for example, night shift and day shift with each other, or you can compare also different weeks with each other. You can see all this, and then you can see the performance also of machines. You can see two machines next to each other with the same job on, and you can see how much is done. The error information is maybe a point for you, what you would like to see when you have your automation on. Many of you mentioned that you want to use your automation during the night, and then it's interesting always that you get an error, but the idea should be that it's like push to stop. Now, it should be not stopped by an error, you should have to push it. So this should be the idea, that you have the only push you have to do is to stop it at the end when you want to stop it. So statistics is number one at the moment here. Live view was, for example, on Monday with Australia, very important for many people, because you have, of course, the possibility to see in real time what your automation is doing. And that's also interesting from home, for example, on the weekend, if it's still running and how it's still running. And the job list was also at the last time on Monday more important for the customers, because you can see, for example, what is the job which is coming next. And if you are, for example, a job shop, and if you are at your customer, you could even adjust there something in your job list. So that's always interesting, that every market and every statistics, it's different. But here, for example, for you now, statistics, it's the most important.
Yeah, and with this overview of our Cockpit, we are nearly on the end of our Digital Technology Day. We hope you had a great time with our show regarding our machines, regarding our software, and we could also answer your special questions regarding our products and software. Maybe some final words from your side regarding to stay in contact also in the future with you. I think a good option is the Bystronic landing page.
I think yes, that's easy. And 3 steps, you can book your individual demonstration. We have got already the first registrations now. So thank you for this. It's really easy. 3 steps. You choose your machine, you choose the date, and you send it. 3 steps, really easy, in less than 3 seconds. You can manage to do this if you would like to have more information from us. What you can do also, many of you do it anyway already, you follow us on Facebook and Instagram, so you're of course welcome to follow us with this. We hope it was interesting. With this, we hand it back to our colleagues, Sarah and Sebastian, downstairs, and we hope we see you again soon. Ciao.
Ciao.
Dear ladies and gentlemen, we are now at the end of our Digital Technology Day.
We had a lot of fun today and want to thank every one of you for joining in.
For more detailed information and features about our products, feel free to book your individual demo right on time.
Thanks to our entire team behind the scene, thanks to our speakers, thanks to our experts, and of course, a lot of thanks to you for tuning in.
So I hope you all enjoyed our Digital Technology Day, and see you next time.
See you next time.
Goodbye.
Bystronic is a leading global supplier of system solutions for the sheet metal industry. We provide laser cutting systems, bending systems, automation, software solutions, and comprehensive services. Sorry, I need a sip. Ah.
He's good, no?
Mommy,
Let's say he has a confident voice, yes.
Shall we? Client happy?
Client happy, but please get to the end of the line this time and add a little verve.
The verve is there. You may not be able to hear it right now, but you will in post-production.
In post? We are in...
We offer worldwide presence and competence. We speak your language and understand your needs. We are here for you. Sorry, we are here for you. I mean, I hear the words, but I'm not getting anything from them, you know?
Could you please just say the lines?
May I?
Please.
It means that we offer much more than just a machine. We support our customers with flexible financing models, training, maintenance, a long-term spare parts service, phone hotlines and online support. And we also operate local sales and support offices in many, many countries.
Yes. Now you see, now it's coming alive. We should be saying this. It is more text, though, so we will have to renegotiate with my agent.
Can't you just record it and we'll look at it later?
Well, I'd love to, but my agent would kill me.
If only. Fine then, continue with the script.
Right you are. Where were we?
At customer service and post-sales services, would you believe?
Rolling.
We don't simply develop machines that cut or bend sheet metal. No, our customers need flexible systems for ever-changing order positions and batch sizes. Automation to achieve top productivity with integrated systems and the right software that cross-links everything. Bystronic stands for Swiss quality. Sorry.
Really?
Swiss quality. I mean, it's a bit of a cliche, isn't it? And actually, while we're at it, your slogan, best choice, kind of sounds like we've just won the buzzword bingo.
Guys, if you want to sort this out, I'm just going to pop out for a smoke.
Let me explain. First of all, Swiss quality. Do you know the Bystar fibre? The Bytrans cross or Bysoft? Have you ever seen them laser cutting and bending those sheets? It's like butter. Once you've seen it, you can't help but be excited. The beauty of a laser cut. The precision of a bent metal sheet, from very small to very large, but all with the precision of Swiss clockwork, perfectly formed and expertly fitted. Now, best choice. When you say yes to a partner, be it in business or private life, you make a commitment to the future. Bless you, Katie. Now, you're still young, but one day, you're going to want someone for the long run. Someone who shares your vision for the future. You see, at Bystronic, we think about tomorrow's sheet metal processing. We have some footage of that, right? In what we call the smart factory, variable orders will be produced automatically on flexible systems. A clear vision and state-of-the-art technology means cost and process optimization, which in turn means higher earnings. And who's behind this success? The employees of Bystronic worldwide. Now, you'll say that's just another cliche, but nobody else sets new standards like they do. With their enthusiasm, their ideas, and their know-how. Actually, I stand corrected, because our success is also due to our clients. It's their feedback that we use to develop new technologies. And until they are perfectly functioning, we will not launch them. And none of our employees will settle for less. Not in Asia, not in America, not in Europe, not in Switzerland, nowhere. And that's what we mean by best choice. I'm sorry, I think I interrupted you.
Did you record this?
Sorry, did he say something? I couldn't hear a word.
He says we're done.
Really? That looked like more words to me.
No, really, we're done. But you can stay here till 5 because it's in your contract.
Oh, no, I'm more than happy to do another version. We'll just speak to my agent later on. That's no problem. Gentlemen? Hello?